You might be lagging somewhere in solving this problem, which you can't deny. Follow this video, it will immensely help you in getting a simple solution. So here is a problem from eigenvalues and eigenvectors, and we have to determine the model matrix for the given A matrix and hence diagonalize A. So for this, the solution here is, first of all, we have to find the characteristic. So this is the characteristic equation of A is, of the matrix A is, this is A minus lambda I is equal to 0. So for this, so we have to subtract. So we have to subtract lambda from each and every diagonal element. That is 3 minus lambda 2, 4, and this is 2. This is 0 minus lambda 2, and this is 4. This is 2, and this is 3 minus lambda is equal to 0. First of all, I am going to calculate all the diagonal elements. So for that, so this will be 3 minus lambda into, so now I have to close this row as well as this column. So if I close this row and column, so this multiplication will be minus lambda times of, this is 3 minus lambda minus 4, and the next one is minus 2. So this is minus 2 times of, now I have to close this row and column. So this will be 2 times of 3 minus lambda, 4 2s, this is 8, and next, so this is 4, so this is plus 4 times of. So now I'll close this row as well as this column, and see, this is 2 2s of 4, and minus of minus plus 4 lambda is equal to 0. Now I have to multiply each and every term with this. So 3 minus lambda times of, this is minus 3 lambda plus lambda square minus 4, and this is minus 2 times of, this is 6 minus 2 lambda minus 8, and this will be 16. 4 4s are 16 plus a 16 lambda is equal to 0. So this will be 3 minus lambda times of, this is lambda square minus 3 lambda minus 4, and this is minus 2 times of minus 2 lambda minus 2 plus a 16 plus a 16 lambda is equal to 0. So if I multiply with 3, so this is 3 times of lambda square minus 3 lambda minus 4 minus lambda times of lambda square minus 3 lambda minus 4, and this will be plus 4 lambda plus 4 plus a 16 plus a 16 lambda is equal to 0. So if you see, if I multiply, so this will be 3 lambda square minus 9 lambda minus 12, and this is minus lambda cube plus 3 lambda square, and minus of minus plus 4 lambda, and this is again 4 lambda plus 4 plus a 16 plus a 16 lambda is equal to 0. If you observe, there is only single lambda cube. So this is minus lambda cube, and if you observe this one, so this is lambda square, so this will be plus a 6 lambda square, so this is plus a 6 lambda square, and again if you observe this one, lambdas, so this is minus 9 plus 4 and this is 16, so this is 24 minus 9, so this will be plus 15 lambda, so plus 15 lambda, and again if you observe this one, so the constants here are, here it is minus 12, and if you go like this, this is 20 minus 12, so this is plus 8 is equal to 0. If I multiply with minus, then lambda cube minus 6 lambda square minus 15 lambda minus 8 is equal to 0. So now I have to find the factors for this. So this is lambda cube quotient is 1 minus 6, this is 15, and this is minus 8. If I check with minus 1, so if I check with minus 1, see what happens here, 0, so this will be minus 1, so this is minus 7, again if I multiply, this is plus 7, and this is minus 8, and this is plus 8, so minus 1 into minus 8 is plus 8, and I got the value as 0. Again if I check with negative minus 1, and see what happens here, so this is 1, and this is minus 1 again, this is minus 8, and this is plus 8, and see this value is also 0. So see, our roots will be lambda plus 1 into lambda plus 1, and this is lambda minus 8 is equal to 0. So I got the roots as minus 1 comma minus 1 comma plus 8. So these are our these are the eigenvalues. So after getting the eigenvalues, what we have to check? So we have to go with the eigenvectors corresponding to the eigenvalues. So first of all, our lambda values I'm showing. So these are, so lambda is equal to -1 comma -1 comma +8, and these are the lambda values. And now I'm going to find out the eigenvector. So the eigenvector corresponding to lambda is equal to, this is -1. So in this case, so in place of lambda, so I have to substitute, in place of lambda I have to substitute -1. So for that, see what happens here. So this will be 3 plus 1, 2, 4, and this is 2, and in place of lambda if I keep -1, this will be +1, 2, and this is 4, 2, and this is again 3 plus 1. So if you observe this one, so this will be 4, 2, 4, and this is 2, 1, 2, and this is 4, 2, and 4. So using this first diagonal element, I have to make these two zeros. So in order to make this 0, so I have to use R2. So this is 2 R2. I have to multiply with 2 and subtract with R1, row 1. Then this will be 0. So using this, I have to make row 3 0. So row 3 will be, see here, 4 minus 4. So R3 will be as it is and minus R1. So using this, I have to make these two 0, and it's very simple here. Row 1 I am not disturbing. It will be like that. That is 4 to 4. Row 1 it will be like that. And row 2 operation, see, this is the rough work I am using. This is 2 R2 minus R1. So 2 R2. So row 2 have to multiply with 2. 2 2s are 4. 2 1s are 2. And again 4 minus R1. What is R1 here? This is 4 2 4. So this will be 0 0 0. And R3 operation is, row 3 operation is nothing but row 3 minus row 1. So what is row 3? 4 2 4. So this is 4 2 4. Minus row 1 is again 4 to 4. So this will be 0 0 0. If you observe this one, the rank of the matrix is 1, and the number of unknowns is, it's a 3 by 3 matrix, x1 x2 and x3, there will be 3. Therefore number of independent solutions which we can take in D, number of independent solutions is n minus r. So this is 3 minus 1. So 2 independent solutions we can choose by our own. So this can be written as 4 2 4 0 0 0 0 0 0 into, this is x1 x2 and x3 is equal to 0 0 0. So this will be 4x1 plus 2x2 plus 4x3 is equal to 0. Now I have to choose two solutions by my own. So this will be, see how I'll take. So x1 is equal to, I took, so x2 is equal to k1 and x3 is equal to k2 of my choice. So this is 4x1 plus 2k1 plus 4k2 is equal to 0. So 4x1 is equal to minus 2k1 plus 4k2, and x1 is equal to minus 2 by 4 k2 minus 4 by 4 k2. So x1 is equal to minus 1 by 2 k1 minus k2. So our x1, x2, x3 values are, if you observe, what is k1 here? Minus k1 by 2 minus k2, and x2 is equal to, this is k1, and x3 is equal to, this is k2. So this is k2. So this will be, if I take k1 common, so this will be minus half and 1, and this is 0. And if I take k2 common here, so this will be minus 1 0 1. So if I multiply with my 2 here, so this will be minus 1 2 0 into k1 by 2, it's again a constant, and minus 1 0 1 into k2. So these are, so if you see 1 minus 2 0 and minus 1 0 1, so these are the eigenvectors. So these are the eigenvectors corresponding to lambda is equal to minus 1. So our next, so the matrix here is ready. So one is minus 1 2 0 and minus 1 0 1. So this is minus 1 2 0, and the next one is minus 1 0 1. So next I have to find out the eigenvector with respect to the eigenvalue lambda is equal to 8. For that, so what is the eigenvector? So this is the eigenvector which I am going to solve for lambda is equal to 8. For that, again I have to keep lambda is equal to 8 in place of this one. So wherever I find lambda, I have to keep 8 here. That is 3 minus lambda 2 4. This is 2, this is minus 8 2, this is 4 2, and this is 3 minus 8. So this value will be minus 5 2 4, and this is 2, this is minus 8 2, and this is 4 2, and this is minus 5. And after getting these values, so first of all I have to choose this one, first diagonal element, and make these two 0. So for that R2 value will be, I have to multiply with 5. This is 5 R2, and this is plus, this is 2 R1, and next R3. In order to make R3 0, I have to multiply with 5 R3 plus, this is 4 R1. This is 4 R1. So now here if you see, so R1 I am not disturbing, that is minus 5 4 2, and R2 here, so R2 is, if you observe here the value, this is 5 R2 plus 2 R1. So we have to multiply R2 with 5. 5 2s are 10, and this is 5 minus 40, and 5 2s are again 10, and we have to multiply with 2 here, that is minus 10. 2 2s are, this one is 4, and if I multiply with 2, so this will be 4 2s are 8, so this will be 0. So this will be 0, and if you see, this is minus 36, and 10 plus 8 is 18. And see, how about this R3? R3 will be 5 R3. So this is 5 R3 plus 4 R1. So we have to multiply R3 with 5. So this is 5 4s, this is 20. 5 2s, this is 10. And this is minus 25. And we have to multiply row 1 with 4. So this will be minus 20 plus 8, and this is 16, and see, this will be 0, this is 18, and this is minus 9. Minus 9. See, using the second diagonal element, so using the second diagonal element, I'll make this 0. So the next operation will be R3 will be, this is 2 R3 plus R2. So it's so simple, I can multiply with 2 and add this one. So this will be minus 5 2 4, 0 minus 36 18, and 0 0. So if I multiply, this will be 36 plus 36. If I multiply with 2, this is minus 18 plus 18. So this is 0. And my next operation for my convenience is, so R2 is equal to, R2 affected as R2 by, this is minus 18. So this will be minus 5 2 4 0, and this is plus 2, and this is minus 1. Minus 1 0 0 0. And if you observe this one, the rank of the A. So rank of the matrix is 2, and number of unknowns, the number of unknown values are x1, x2, and x3. They are 3 values. Therefore, the number of independent solutions are, this is n minus r, 3 minus 2, that is one solution we can choose by our choice. So this is minus 5 2 4, this is 0 2 minus 1, 0 0 0 into, see here, x1, x2 and x3 is equal to 0 0 0. So this can be written as, this is 5x1 plus 2x2 plus 4x3 is equal to 0, and this is 2x2 minus x3 is equal to 0. Only one solution we can take on our choice. Therefore x3 is equal to k I have taken, and if I substitute, then 2x2 minus k is equal to 0, and 2x2 is equal to k, and x2 is equal to k by 2. So after getting k, so I have to substitute in this equation, that is minus 5x1 plus 2x2 plus 4x3 is equal to 0. This is 5x1 plus 2 into, so this will be k by 2, and this is 4k is equal to 0. So now I can cancel this k, and this will become minus 5x1 plus k plus 4k is equal to 0. So 5x1 plus 5k is equal to 0, and 5x1 is equal to 5k, and x1 is equal to k. So after getting the k1 value, so x1, x2, x3 values will be, see what is our x1 value, this is k. So k2, x2 is equal to k by 2, and this is k again. So if I take k common here, so this will be 1 by 2, 1 into k. So if I multiply with 2 here, 2, this is 1, and this is 2, and this is k by 2, and this is the eigenvector corresponding to, this is the eigenvector corresponding to lambda is equal to 8. So this is 2, 1, 2, remember. So this value is 2, 1, 2. So now this is 2, 1, 2. So this is nothing but the model matrix P. And after getting all the model matrix, so we got the model matrix as, see here, the model matrix P is nothing but, this is minus 1, 2, 0, and this is minus 1, 0, 1, and this is 2, 1, 2. And now we have to find out the det P. So determinant of, so det P is nothing but minus 1 times of, this is 0 minus 1, and this is minus of minus plus 1, this will be 4 minus, so if I close this row and column, this will be 4 minus 0, and this is plus 2 times of, this is 2 minus 0, and det P is equal to minus into minus plus 1 plus 4 plus 4, and my det P value is 9. So if you see, it is 9. So now again we have to find out which value. So we have to find out cofactor for this. So P is nothing but minus 1, 2, 2, 0, 1, and 0, 1, 2. So what is the cofactor? So the cofactor of P is nothing but, see here, this is plus minus plus, minus plus minus, and this is plus minus plus. So now, so we have to calculate all these values here. So in order to calculate all these values, it's so simple that, so in order to find this, so we have to close this row as well as this column. So if I close this row and column, this will be 0 minus 1. So this value is minus 1. So our P inverse value will be minus 1. And after that, if you see the next position here, so this will be, if I close this, this is 2 minus 0. So 2 minus 0 is nothing but, this value is 2. So the value here will be 2. And the next value, if you observe, this is 2 into 2, this will be 4. So this value will be 4. So in this position, so this will be 2 minus 0. So this value is 2. And the next one, in this position, if you check, then this value will be minus 2, minus 2. So this is minus 2, this will be minus 4, and therefore this will be, we can write as plus 4. And the next one here, so in the middle term will be, if we close like this, minus 2. So this is minus 2, the value is minus 2. And for the last one, so this for this position, see here, so if you observe, this is minus 1, minus 0. So this will be minus of minus plus 1. And again for this position, see here, this will be minus 1. So the value here is minus 1. And for this position, see the value here, if you observe, this is minus 1, minus 4. So minus 1, minus 4 is minus 5. And again already there is minus plus. So for this position, this is 0 minus of minus plus 2, and this value is plus 2. And after finding the cofactor matrix, so adjoint of A, so adjoint of P is nothing but the transpose of this will be minus 1, 4, minus 1, and this is minus 4, minus 2, 5, and this is 2, 1, 2. So what is P inverse? P inverse is nothing but adjoint of P by determinant of P. So what is determinant of P? Det P is nothing but 9. So this will be 1 by 9 times of minus 1, 4, minus 1. This is minus 4, minus 2, 5, and this is 2, 1, 2. So after getting P inverse, so we have to diagonalize the matrix. In order to diagonalize the matrix, so we have D is equal to, see here, D is equal to P inverse AP. So D is equal to, what is P inverse here? So just now I found, so P inverse is nothing but 1 by 9 times of, this is minus 1, 4, minus 1, this is minus 4, 2, minus 5, this is 2, 1, 2. And what is A? A is nothing but our question here. So what is the question here? So question, I'll show you. 3 2 4, so this is 3 2 4, and again 202 and 4 2 3, and this value will be 4 2 and 3, and again this is P here, model matrix. See, I'll show you the P model matrix here. -1 -1 2, this is 2 0 1 and 0 1 2. So now if I multiply, see what happens here. D is equal to 1 by 9 times of, this is -1 4 -9 -4 -2 5, this is 2 1 2 into, so if I multiply this one, then see what happens here. So this is -3, see, this is +4 and +0, and if you multiply, this is -3 +0 +4. If I multiply, this is a 6 +2 +8, and if you see, this will be -2 +0 +0, and this is going to be -2 +0 +2 ones are 2, and this is 4 +0 +4. This is -4 +4 +0, and this is -4 +0 +3, and this is going to be 8 +2 and 6. And see here, so all our values are ready, and this will be D is equal to 1 by 9 times of -1 4 -1, this is -4 -2, this is 5, and 2 1 2. So this will be, see here, this value is 1, and this is 1, and this value is 10 16. So this is -2, and this value is 0, and this value is 8, and this value is again 0, and this value, this is -1, and this is again 16. So if you observe this one, so this value is 0, this value is 0. And now if I multiply this one, see what happens here. 1 by 9 times of, if I multiply, this is -1 -8 -0, and this is -1 +0, and this is +1. This is -6 +32 and -16, and if you see, this is -4, and this is +4 +0, and this is -4, this is -0 -5, and this is -64, and if I multiply, this is -16, and this is 80. So 16 5 80, and this is 2 1s are 2, and this is -2, and this is 0, and this is 2 -0 -2, and this is 32, and this is 8, and this value is 32 again. So 8 and 32, if you observe, so this is +32 -32, and if you see, this is +80 -80, this is +2 -2, +1 -1, and +4 -4 +2 -2, and see what remains here. So D value is nothing but D is equal to 1 by 9 times of, this is -900, and this is 0, and -90, and this is 00, and this value in total, it will be 72. So if I send this 9 and divide, then this value will be -100 and 0 -10 and 008. So observe this one. So these are all the lambda values, eigenvalues. I'll show you all the eigenvalues here. So here the lambda values, just now I found, that is -1 -1 8. So here also, that as it is diagonalized, and the values here are -1 -1 8, and this is the only way for our cross check. And thank you so much for watching and staying till the end. So please practice, even though it's very lengthy, it's very important. And meet you in my next video coming up very soon. I'll keep bringing up these videos for you. Stay connected and pass it on to your friends, because they also need it. And thank you so much. And before you leave, please subscribe to this channel and support this channel. Thank you so much.